Today we'll be covering Lesson 1 in Unit 1. So Unit 1 is Sequences, and this is Checkerboard Borders. So our objective today is I can use an expression to accurately model a pattern in 1 out of 2 problems. What's an expression? We'll talk about that a little bit later. And it looks like we'll be talking about patterns today, seeing patterns in things. So questions to think about. When I look at a pattern, how can I describe what's changing, what's staying the same? Can seeing groups help in understanding diagrams? So maybe grouping will help us see patterns. And how do variables express the way we see patterns? Can we use variables? So we're going to start with these. This pattern right here. There are 5 by 5 white tiles in the middle. Let's take a look. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5 down. So this is a 5 by 5 square, and then there's a 2-tile border around the edge. So how many purple tiles are there here? Let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wait, was this one 14? Or was this one 14? I think this one was 15. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Wait, did I already count that? Did I start with this one? Maybe it's 27. Oh, I don't remember. I don't want to count them again. That was annoying. Well, it could be 28, 29, somewhere around there. That was really hard to count all of those, though. So is there an easier way to count them, do you think? Is there something we can do to make counting these tiles easier? Well, let's see. Maybe we can find some symmetry. Maybe we can find some symmetry, and that will help us count them. Let's see. Well, maybe if we draw a line here, and we draw a line here. What do you think? Will that help us count these maybe a little bit better? Well, now I see that on the top I have a couple of rows, and on the bottom I have a couple of rows, and they look exactly the same. They look like mirror images of each other. So really, I should only need to count one of them, and then I can assume that's the same number for both, right? And the same on the sides. So 1, 2, 3, 4, 5 on the sides. I would expect there to be 5 over here and 5 over here. They'd match. And then on the top and bottom I have 1, 2, 3, 4, 5, 6, 7, 8, 9, which was way easier to count than all of them. And so I can go 5 plus 5 plus 9 plus 9. Let's see what we get there. 5 plus 5 is 10, plus 9 is 19, plus 9 more is 28. So that would be 28 total. So that's pretty close to what we got before, right? We were like, it's around 28, might be 27, might be 29. But this way, we're more sure of our counting. We only had to count a couple of little ones. And we added together and got 28. So let's see. Let's try another grouping method. Okay, so we've got 4 lines on here now, and it looks like we have some symmetry. We've got corners. Let's see, corner, 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 corner. And each of them has 2. Each of them has 2 tiles. 2 up here, 2 over here, and 2 down here. So 4 corners times 2 tiles each. And then on the sides, we have 1, 2, 3, 4, 5. And all of those are symmetrical. All of the sides are symmetrical. So we're going to add 4 sides times 5. And we just simplify that. 4 times 2 is 8. 4 times 5 is 20. We add those together, we get 28 again. So you can see, even if we group them in different ways, we should still get the same answer as long as it is a relevant and accurate grouping. Interesting. Okay, so let's move on. In preparation for going back to school, the school administration plans to replace the tile in the cafeteria. they would like to have a checkerboard pattern of tiles 2 rows wide to surround the tables and serving carts. Okay, I guess this is a school that has a cafeteria. I don't know. I've never been to a school like that, but we're going to replace the tiles in the school cafeteria. So this looks very similar, doesn't it? Like if we're looking down on a cafeteria, this could be the edge, the border with the color tiles. And then in the middle, we have white tiles where the serving carts and tables are. So if we count these middle tiles now, we have 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. So this is a 6 by 6 square, and we have that same 2-tile border around the edge. Do you think we can use some of the same grouping methods we used before? Let's give it a try. So we have our diagram divided up into groups again, and let's take a look at how many we have now. We have 2 in each corner again. The corners look like they stayed the same. And now how many do we have on each symmetrical side? We have 1, 2, 3, 4, 5, 6. 6 up here. This one looks like it's the same, so we have the same side all the way around. So on our corners, we have 4 corners times 2 tiles each. And on our sides, we have 6 tiles. Whoops. We have 4 sides times 6 tiles each. So 4 times 2 is 8, plus 4 times 6 is 24. We add those together, we get 32. So we can see that there are 32 tiles here without having to count them all individually. Now, can we represent our counting strategy as an expression? Interesting. So let me draw these groups again. So there's our grouping. You can't quite get this line right on there, but it's pretty close. And we said we have 2, 2, 2, and 2, and then 6, 6, 6, and 6. So what is an expression anyway? What is an expression in math? Well, an expression, we've talked about equations, not in this class, but I'm sure you've seen them before. Something like y equals 3x plus 2. That would be an equation. You can think of an expression as everything on one side of an equation. So an equation is called that because it has an equal sign in it. An expression is just numbers and variables put together. Multiplied, divided, added, all those things we can do in expressions. It's just one side of an equal sign. So what might we put on one side of an equal sign that would equal the number of tiles here? So we'd have 4. I need to grab a pen. We'd have 4 corners times 2 tiles plus 4 sides times 6 tiles. These are corners. These are sides. That's exactly what we wrote on the last slide. This is an expression. 4 times 2 plus 4 times 6. That is an expression. It tells us how many tiles there are total. So that is the answer to this. This is how we write an expression. Okay, so what if the middle square is 25 by 25 tiles? Can we figure out how many color tiles there would be? Oh, interesting. So we have 25 in the middle, 25 on the top and 25 down the side. Well, we might have to look for a pattern now. We might have to look for a pattern between the 5 square and the 6 square and see if we can extend it to 25. So let's go back and look at the 5 square. Scroll way back here. We had 5 squares, 5 tiles on the white, and 5 color tiles on each side. The corners have stayed the same every time. The corners are the same, no matter how big. Well, on the size 5 and the size 6, the corners have stayed the same. The sides here were 5 white tiles and 5 purple tiles. So let's look at the green one we did. Now we have 6 white tiles. The corners are again the same, but the sides went up 1. So the white square went up 1 and the sides went up 1. So do you think it's fair to say that the corners will always have 4 corners times 2 tiles? The corners will always be the same. And then the sides will be however many tiles the white tiles have. See how we have 6 white tiles and then we have 6 color tiles. That might make logical sense because these are alternating, right? So we have a color and a white and a white and a color. So for every white tile, we have 1 color tile. 1, 1, 1, 1, 1, 1, 1, 1, and it goes up. So if we say the side is n, then we would have 4 sides times n. Now what do we mean by n? N kind of freaks us out. We have variables. What do they mean? We've thrown letters into math and everything goes into chaos. What do we mean by n? Well, n is just a placeholder for a number. It could be a side of size 5, a side of size 6, or a side of size 25. It could be any of those numbers. It could be any other number we choose too. Any positive number at least. So that's all we mean by n. It's just holding a number inside of it that maybe we don't know, or it could be replaced. We could make a bigger cafeteria and it could have more tiles. So if I scroll back down to our question here, what is our expression for an n by n? This is a capital N by a capital N. Well, we decided that the corners have 4 corners times 2 tiles, plus the sides, which have 4 sides, and they have n color tiles. So if we simplify that, 4 times 2 is 8, and then 4 times n is just 4n. That can be a simplified way of writing it. We don't have to write the multiply symbol. We understand that writing them together like that just means multiply. So that is our expression for any n-sided. So our question was, what if the middle square is 25 by 25? So we can put 25 into that expression and see what it simplifies to. 8 plus 4 times 25. 4 times 25 is going to be 100, so 8 plus 100. We know that it would have 108 tiles, and we don't have to draw it all out. Isn't that cool? So that was everything in today's lesson. I can use an expression to accurately model a pattern in 1 out of 2 problems. We talked about what expressions were, and we talked about seeing patterns in diagrams.